Today, let us start thermodynamic process. First, we define a thermodynamic process. It is defined as the change from one equilibrium macro state to another macro state. Here, macro stands for a big, that is, big changes in pressure, volume, and temperature, etc. Next, we take isothermal process. It is a thermodynamic process in which temperature remains constant. Thus, in this process, change in temperature dt is equal to 0, and from the equation du is equal to internal energy change, du is equal to ncv dt, it will be 0 because dt is 0. Then from first law of thermodynamics, dq is equal to du plus dw. Because du is 0, therefore dq will be dw. This figure 1 represents the isothermal process curve. Here, gas goes from state A to B, from pressure P1, volume V1 and temperature T, to point B where pressure is P2, volume is V2 and temperature is T. Thus, throughout the process, temperature is constant. Next one is the isochoric process. It is a thermodynamic process in which volume of the gas remains constant. Thus, in such process, change in volume dV is equal to 0, and therefore external work done dW will be PdV will be 0 because dV is 0. And from first law of thermodynamics, dq is equal to du plus dw. Because dw is 0, therefore dq will be du. Figure 2 shows the graph AB, which is isochoric curve. At point A, pressure is P, volume is V and temperature is T1. Here pressure is P1, volume is V and temperature is T1. At point P, pressure is P2, volume is V and temperature is T2. Thus, the volume is constant throughout the process. Next, we take isobaric process. In isobaric process, pressure of the gas remains constant. Thus, we take isobaric process. It is a thermodynamic process. Thermodynamic process in which pressure remains constant. Figure 3 shows the PV diagram for isobaric process. Here, at point A, pressure is P, volume is V1, temperature is T1. At point B, pressure is P, volume is V2, temperature is T2. Thus, from A to B, pressure is throughout constant, and this curve is the isobaric process. In this case, first law of thermodynamics gives dq is equal to du plus dw, that is ncv dt plus P dV. Now we find the expression for work done, expression for work done in isothermal process. Rather we take first law of thermodynamics. First law of thermodynamics. This law is based on the law of conservation of energy, and it states that the total heat given to the gas in a closed system is equal to the sum of the external work done and the change in internal energy of gas. Thus, heat given to the gas dq is equal to du plus dw, where du is change in internal energy of gas, which is equal to NCV dt or mCV dt, and dW is external work done, which is P dV. Here N is number of moles, M is mass of gas, dt is temperature change, CV is molar heat capacity, at constant volume. Similarly, C small v is specific heat capacity at constant volume. Thus, according to first law of thermodynamics, dq is equal to du plus dw, where du and dw are given according to these relations. Okay. Next, we take work done during the expansion of, or work done during isothermal process. Now we change external work done during isothermal process. Suppose n moles of an ideal gas be expanded from volume V1 to V2. Then we have to find the expression for the total work done. We know that the work done during a small volume change dV is given by the relation dW is equal to P dV. Suppose this is equation 1. For n moles of ideal gas, PV is equal to n RT. Therefore, P will be equal to n RT by B. Equation 2. From equation 2, equation 1 gives dW is equal to nRT by V into dV. Equation 3. Therefore, total work done will be the integration of equation 3 from volume V1 to V2. That is, dW will be equal to, here nRT being constant can be taken out of integral 1 upon V dV from V1 to V2. So you get W is equal to nRT log base E of V from V1 to V2. When you open this integral, this bracket, you get nRT log V2 minus log V1, and from relation log A minus log B is equal to log A upon B, you can write it as log V2 upon V1. So W will be equal to nRT log V2 upon V1, and you know log E is equivalent to ln. Therefore, you can say it as nRT ln V2 upon V1. You can also write P1 upon P2 in place of V2 upon V1. Because P1 is equal to P2 V2 from Boyle's law. Thus, in this case, we find the expression for work done as W is equal to nRT ln V2 upon V1 equal to nRT ln V1 upon V2. Thus, W is equal to nRT ln V2 upon V1 or nRT ln V1 upon V2. This is the work done in isothermal process. Here log base E stands for ln, because in your calculators ln is seen in place of log base E. Thank you.